Okay, so imagine this for a moment. Imagine a world so distant that the sun looks like just another bright star. A world that was once called a planet, and then stripped of that title. Publicly downgraded after nearly 80 years. And now imagine something even stranger. What if we were wrong? In 1930, an astronomer named Clyde Tombaugh identified a faint moving dot in the night sky at Lowell Observatory in Arizona. That dot became Pluto. For decades, it completed the neat lists children memorized in school: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. It was small, it was distant, but it was ours. And then the solar system grew. In the 1990s and early 2000s, astronomers began discovering large icy objects beyond Neptune. One of them, Eris, was nearly the same size as Pluto. If Pluto was a planet, then Eris had to be one too. And if Eris was a planet, there might be dozens more waiting to be found. The solar system was about to become crowded. So in 2006, the International Astronomical Union voted to redefine the word planet. 3 criteria. It must orbit the sun. It must have enough mass for gravity to shape it into a sphere. It must clear its orbital neighborhood. Pluto satisfies the first 2 perfectly. It orbits the sun every 248 Earth years. Its gravity shapes it into a sphere, but it fails the third. It shares its orbital zone with countless objects in the Kuiper Belt, a vast region of icy debris left over from the formation of the solar system. Because of that, Pluto was reclassified as a dwarf planet. The decision passed. Textbooks changed, and Pluto was removed from the list. But the universe didn't change, and in 2015, we finally saw why. NASA's New Horizons became the first spacecraft to fly past Pluto after traveling for nearly a decade across billions of kilometers. What it sent back was not an inert ice ball. It revealed a world with towering water ice mountains rising more than 3,000 meters high. It revealed Sputnik Planitia, a massive heart-shaped glacier made of nitrogen ice. It revealed layered blue atmospheric hazes stretching hundreds of kilometers above the surface. Pluto has weather. Pluto has seasonal cycles. Its atmosphere expands and collapses as it moves closer to and farther from the sun. Even more surprising, the surface shows almost no impact craters in certain regions, meaning it is geologically young. Something inside Pluto is active, possibly a subsurface ocean kept liquid by residual internal heat. This is not what scientists expected from a failed planet. This is complexity. This is structure. This is activity. And activity changes the conversation. Pluto is 2,376 kilometers in diameter. That makes it smaller than Earth's moon, but larger than many known moons orbiting other planets. It has 5 known moons of its own, including Charon, which is so large relative to Pluto that the 2 bodies orbit a shared center of gravity outside Pluto's surface. Some scientists argue this makes Pluto and Charon a binary system. It rotates backward compared to most planets. It has an elliptical orbit that is more tilted and stretched than any of the 8 recognized planets. For 20 years of its orbit, Pluto is actually closer to the Sun than Neptune, and yet they never collide, because they are locked in a 3-to-2 orbital resonance. Every time Pluto completes 2 full orbits, Neptune completes 3. Their gravitational interaction is synchronized, precise, stable. It's not chaos, it's choreography. Now imagine a different early solar system. Imagine Pluto forming in a slightly denser region of the Kuiper Belt. Imagine it accreting more mass, absorbing nearby icy bodies, growing larger. If Pluto were roughly 8,000 to 8,500 kilometers in diameter, its gravitational dominance would be far greater. It could have cleared its orbital path. It would meet the third criterion. There would be no debate. It would be called the ninth planet without hesitation. But that additional mass would alter the gravitational equilibrium of the outer solar system. Its interaction with Neptune would strengthen. The resonance could shift. Not immediately, not dramatically, but over millions of years, orbital perturbations could accumulate. Small gravitational tugs, minute deviations, until the architecture of the Kuiper Belt looked completely different. Maybe Pluto is exactly the size it needs to be, not too large to destabilize the outer planets, not too small to remain geologically interesting. Balanced. And here's something even subtler. The definition of clearing its orbit is not absolute. Earth does not exist in empty space. It shares its orbital path with thousands of near-Earth objects and asteroids. Jupiter shares with Trojan asteroids. Neptune shares with Kuiper Belt objects. The difference is dominance, mass, gravitational influence. So when we say Pluto hasn't cleared its orbit, what we really mean is that it does not dominate its region the way the 8 planets do. The definition is technical, but it is also human. The solar system does not recognize categories, it recognizes gravity. Pluto did not shrink in 2006. Its mountains did not collapse. Its atmosphere did not disappear. Only the word attached to it changed. And yet the emotional reaction was intense, because Pluto was more than a celestial object. It was a symbol. It represented the edge of what we knew, the boundary of childhood diagrams. Removing it felt like losing something. But science does not move by sentiment. It moves by refinement, by redefining, by correcting itself when new data appears. And sometimes that means demoting a planet. But here is the deeper question. If tomorrow the definition changed again, if the criteria were adjusted, if Pluto were officially restored as the 9th planet, what would actually change? Nothing in space, only in us. The universe would continue its silent mechanics. Pluto would continue its 248-year journey around the sun. Neptune would continue its synchronized dance. The Kuiper Belt would remain a frozen archive of the solar system's formation. And billions of kilometers away, under a dim sun, an icy world would continue existing, indifferent to our debates. Maybe the real mystery isn't whether Pluto is a planet. Maybe it's why we need certainty in a universe built on gradual discovery. Because the more we explore, the more definitions blur. Planets become dwarf planets. Dwarf planets reveal oceans. Simple diagrams become complex systems. And what we thought was settled rarely is. The question is, what small detail are we overlooking right now, in silence? And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.